whether two expressions are correct or wrong? Yes or no? No. Why so difficult? I thought you would be having the proof for me. So that also you cannot prove. Huh? Nobody could do it. Huh? That means nobody has any interest to do that. So since you don't have any interest, I will move on to the next topic. Because I also don't have any interest to show that. Right? Out of my personal interest, I have done it. Okay? But it seems you don't have any excitement. That's fine. So leave it. Why do unnecessary torture yourself or me? Okay? So I'll move on to the next topic. We have tried. Can you show it to me? Evidence? Yes. How far you have tried? Not only 3 steps, sir. Sit down. This is not called tried. You may be smart, but I am smarter than you. That's why I am teaching you in the class. I understand getting admission as a student is difficult in IT matters, extremely difficult as a faculty. That's why I am here. Right? Others wouldn't have been here. So if you act smart, you know that I am smarter than you. I can easily catch you. Okay. But anyway, since you are not interested, I am not interested to pursue that. I have learned it, I have done it, that's it. I am happy with it. Okay, so next we will go for the residual part. So we have done the combinatorial part, that is residual part, minus q1 x1 and then theta 1 tau 1 plus theta 2 tau 2 1 minus q2 x2 and then theta 2 tau 2 2 plus theta 1 tau 1, and here tau ji, which is exponential of minus uji minus ui, right, RT. We can also write this as exponential of minus aji by t, which is the adjustable parameter. Adjustable parameter. Okay, and tau 11 equals to tau 2. Tau 11 equals to tau 2 equals to 1, you can see. And what are uij? So please write down. Uij is the average interaction energy. Uij is average interaction energy for interaction of molecules. Uij is the average interaction energy for interaction of molecules of component I with the molecules of component J. Average interaction energy for interaction of molecules of component I. Average interaction energy for interaction of molecules of component I with the molecules of component J. Average interaction energy for interaction of molecules of component I with the molecules of component J. Okay. So the formula what I got from here. So you can derive it. I am not going to derive it at home because I lost the interest because you are not interested in derivation. You can practice, and of course this will come in the exam. I cannot do it because of course you may be feeling bored or you don't want to do that. That's fine. You can take your leisure time and do it at home, but these things will be coming in the exam. So then gamma 1 residual part, which is q1 into 1 minus then summation j equals to 1 to 2 theta j tau j1 minus summation j equals to 1 to 2 theta j tau ji tau 1j theta j tau 1j summation k equals to 1 to 2 theta k tau kg. So bracket has to be closed. So you have to prove it. The proof can be done the same way what we have done earlier. So capital G by R you have to get from here, then take the derivative with respect to N1 and then get N gamma 1. We have all the x1 plus x2 everything equals to 1, all those things are there. You have to apply them time to time, and we have to get the things, so prove it. So that is your task, not my task. Okay. Now I will be talking about the unique quark what Prosnitz 1980 has proposed. So if you look at Prosnitz paper, PRPSNITZ, Prosnitz et al. 1980. Look at Prosnitz paper. The Prosnitz paper talks about the two parameters. Parameters are, one is the volume parameter, one is the area parameter. Remember that. Unique quark, there are two parameters, right? One comes for the phi I, one comes for theta I. Phi I comes for the volume parameter, right? Ri. Theta I comes for the area parameter. Okay? And when you have many organic components, so chain lengths are very important. So structure parameters Ri and Qi are calculated as the sum of the group volume. They are calculated as the sum of group volume and area parameters. So each group has the parameter called Rk and Qk. So for example, we have a chain like CH3, CH2, CH3O, aldehyde, methyl, all those groups are there. For each group, we have Ri, because these groups are not similar. They are different kind of. So basically, if you have organic substance, there is something called group contribution theory. There is something called group contribution. Something called group contribution. Something called group contribution. So you have CH3, CH2, all these chains will be there. Each chain should be having R. So R of CH3 will be different from R of CH2, different from R of CH3O. Similarly, for the Q parameter, Q of CH3, Q of CH2, Q of CH3O, they are not same. But if for the compound, this compound, I want to calculate Ri, there is a formula based on the structure parameter. Okay? So if there are the number of groups of type K, so basically the effective Ri should be K, summation over K, gamma K I, Rk, and similarly the sum over K, gamma K I, Qk. What is gamma K I? Gamma K I is the number of groups of type K in a molecule of component I. So if there are two, three components. First component, so this organic solvent is very important. We have got complicated organic solvents. So in that case, all those your things will fail. Van Laar and all these inertial models, all those even the two suffix modulus equation, all those things will fail. We have no other option to use the unique quark and unique fact, and in that case, this effective contribution is very important. So now you can see the number of groups of the type K. So we will calculate for a specific Rk and Qk. These are for each group. We have to calculate. You have to get it, and then gamma K is the number of groups, and then get the effective parameters. Okay. Problems are given on the unique quark, unique fact in Whitesidau's book and Sandler's book. You can practice. Problems are given in Sandler and Whitesidau's book. To practice, if you practice, you understand better. I am not doing in the class. To practice them, you can understand better. So next we will go to the unique fact. So unique quark is over. So unique quark, this is the residual part we have done. The question was Ri and Q. Small ri and Q are very simple. If you have inorganic solvent, but organic solvent, we will talk about the structural parameters. We will talk about the group contribution. Then small ri and small q can effectively estimated. After estimation, you calculate the combinatorial part, you calculate the residual part, you get the unique quark calculation. Done. Right? So Ri Q are there actually in combinatorial part, not residual part. So for the combinatorial part, you have to get effective values of Ri and Qi. If you are not getting, then we have a mistake. So all the parameters, all the groups, we have CH3, CH2, CH2. We may have another group called any kind of benzene ring, and then C6H5, another group will be there, right? So C6H5 again, or so many things will be there. We have aliphatic aromatic compounds, their group contribution. All those things are tremendously very important, and those effects to be encountered, to be incorporated in RIQR, and then you can calculate the combinatorial part and the residual part, you calculate accordingly, and based on that one can actually have activity coefficients. Sometimes it may happen that your calculations go somewhere wrong, you have to verify the Gibbs-Duhem equation. So verification of by Gibbs-Duhem equation is very important. At the end of the any activity coefficient model, if you are not able to verify whether Gibbs-Duhem model, you are a serious problem. You are not writing anything what I am saying. You are just looking at me fine, that's okay. So taking class is art. It is not that easy. When the teacher teaches in a class, taking class is an art. And I realized during my student life, because sometimes I will be so lazy to write, and sometimes teacher will talk very fast, I will not write. And when exam time comes, some questions I have in my mind, books will not give the answer, and that will remain unanswered. And that till the end of my life. Okay, teachers will not be that intelligent, but sometimes teachers' experience also counts. Because teacher tries to think sometimes. The thinking, he will get some idea. Those ideas definitely will not be there in the books. So sometimes the compiling the ideas, it will not be there in the books. And we don't have to write because your tendency is whatever I write in the board, you will copy from there. That's okay, but many things will miss out. 80% things will miss out. Okay, so unique work part is done in a systematic manner. We will do now unifact. So what is the full form of unifact? What is the full form of unifact? Unifact means unique quark functional group activity coefficient. Unique quark already you have done. So the functional group activity coefficient, and that will be important for the residual. So combinatorial part it won't be affected. So unique quark will affect the residual part. Unique quark will affect residual part. This GE by RT of R, residual part. Unique quark, unifact will affect the residual part. And what actually happens? Residual part for unique quark is then gamma IR, which is summation K gamma K I ln capital gamma K minus ln capital gamma K I. Now by now we know that what is gamma K, which is given as the number of groups of type K in a molecule I of a molecule of component I. And what is gamma K? Ln gamma K. Ln gamma K is given as Qk into 1 minus ln summation m theta m psi mk minus summation m theta m psi km by summation n theta n psi nm. 1 minus ln summation m theta m psi mk minus m summation n theta m psi km by summation n theta n psi ln. Theta m is defined as theta m xm by n qn xn. What is theta m? Which is surface area of group M. Theta m is nothing but defined as surface area of group M, small m, and xn is the mole fraction of group M in the mixture. Capital Xn is the mole fraction of group M in the mixture. Okay, what is gamma K? Gamma K is the group residual activity coefficient. Gamma K is the group residual activity coefficient. Okay, gamma Ki, residual group activity coefficient, a component. Group is CH3. CH3 is a group, right? And if CH3 is there, for example, acetaldehyde, CH3, CH2, CHI, CHO is there. In this second component also. You have to rename, I don't remember the names, you can rename by IUPAC nomenclature. Okay, I don't want to do that. So it is, so CHO group will be there for the second component also. So those kind of things, so CHO group, we will talk about CHO group will be there. And now the CHO group in the first component and second component, they will differ. That's the way. So once we do the problem on the YBC now or the Sandler, we'll appreciate whether so residual. So gamma K is nothing but residual activity coefficient of group K in a reference solution containing any molecules of type 1. Okay. So definition of this symbol should be quite clear once you do the problem. So I ask you to do the problem. I have the problem done, but I will not do it. It is your duty. Because no need to understand anything, you have to read the stuff. Now you are so mature, you read the stuff, try to solve the problem. There is no concept. Here actually all definitions are there, you have to apply them. It's actually like a bookkeeping work, you have to apply them. Okay? So we have finished the entire spectrum of the activity coefficient models. So let's look at the non-ideal solutions and see how we can actually use these activity coefficient models to understand better the PXY and TXY diagrams. So let's look at the vapor-liquid equilibrium for non-ideal solutions. So we will now move to the vapor-liquid equilibrium. Understand the vapor-liquid equilibrium for non-ideal solutions. Vapor-liquid equilibrium for non-ideal solutions. So vapor-liquid equilibrium we have seen earlier. Our basic equation is FIL equals to FI. Okay, temperature, pressure, all are constant. In that case, those equations are not right. Ideally speaking, you have to write independent algebraic equations to have the degrees of freedom from the best degrees of freedom. Since temperature, pressure are constant, so you can have only equation from the FIL equals to FIB, which is coming from the chemical potential equality. For non-ideal solution, solutions, Fi not equals to Xi Fi star. FIL, I should say. And this was the what rule? Do you remember that? Lewis standard rule. That was Lewis standard rule. And then this will be modified as FIL equals to gamma I Xi Fi star. For I equals to 1 to n is equation number 1. And this gamma I is known as activity coefficient. This gamma is known as activity coefficient. Now we see how activity coefficient will be applicable for your TXY and PXY diagram. PXY diagram, most of the books are done for the ideal solution. Okay? If you use the activity coefficient model, how they will change? We have done PXY diagram for a particular problem earlier. Now you can see how the diagram will change if you go for the activity coefficient model for non-ideal solutions. For vapor phase, we have phi IB equals to FIB by PY. That's the definition of velocity coefficient. Okay? And we can write this as FIB equals to phi IB, which is velocity coefficient, PYI, equation number 2. Okay? For pure liquid component, we have the velocity is termed as, what symbol for the pure liquid component? Fi star, yes, Fi star. This is for the mixture, FIL for the mixture, but Fi star, the pure liquid component. Okay? For the pure liquid component, what's the formula? Fi star equals to, I have done it so many times in the class. Fi star will be coming from the first basic principle. Remember that, we derive it. This is the P tending to 0. It has to go to the vapor phase, and this is your Fi star. Here. So what's the formula for deriving Fi star? Which is integral b minus RT by p prime dp prime 1 by RT. That will give ln f. Yes or no? And from there you get derivations. What is that? So those kind of things should be very much well known to you. I have done so many times. Fi star equals to pardon? Fi equals to pi star. That is for the ideal case. You are just talking like just like a clerk, just like talking, without understanding. You have to understand, madam. That is for the ideal solution. I am not talking ideal solution. Ideal solution, some integral will be there, the integral will go to 1. It is not the case for ideal solutions, not P tending to 0. Right? Please feel thermodynamics. I am failure actually, I can see at the end of 50 lectures. I see that you cannot feel thermodynamics. I am a complete failure. With that end, I think I will end this semester's class of thermodynamics. You could not feel it, even including Ramu. You can't even tell what is that. I am really frustrated to see that. Pardon? Fi star equals to. That's what you are just arbitrary tying now. That's the way. It's like a lottery game. I am here, you just shoot something if something works. I have done it in the class many times. Pure component fugacity. I get the formula how I did it. That means you don't feel the formula. You don't feel it. Of course, you don't need it. For your job, nobody will ask for this formula. And always we talk for the business. It is not required for the business, why should I remember? I thought at least one person in the class. Yes. Fi star equals to? No, you know the formula. Yeah, are you guessing or are you sure from this? If I want to say that this is the way I actually evaluate, this is my reference, what is the formula? You feel for thermodynamics, I don't think you are feeling it. I cannot do the same thing again and again. That is unfair. Anybody? Fi star equals to. I am asking the question. Fi star equals to. Don't tell any stories, please. Fi star equals to, which is a pure component fugacity. Fi star equals to. Fi star equals to. Pardon? I have done in the class many times.
Sir, exact into exponential 1 by RT.
Exact
Exponential 1 by RT.
Exponential 1 by RT.
Integration from P sat to P and real.
What is that? P sat to? P sat to P? BL dP prime. Took so much time, right? Because, and also you are just seeing the formula. By seeing that you should tell that. That's the thing. Because if you feel for that, because you have to come to this part. This will give the gas phase fugacity. Then you have to come here, and that's why the P sat P to come in. That part actually go as F sat. That is the way physically or philosophically I try to remember instead of mugging, because I know that my teaching is bad. I really feel sorry for that. That's why you don't feel thermodynamics. But I don't know how to feel, how you to feel thermodynamics. That will be my topic of research. Maybe another decade. Maybe after another 10 years, I will see that I am a successful teacher who can feel thermodynamics. Maybe I can feel. I don't know. That's a big challenge to me. But today I can see that we have not done anything. That's good. So this is the way Fi star is actually there, exact, and this will actually be 1 because with the P tending to 0 is because these are very close. Okay, P sat and P tending to 0. So that way we have done already for the Rao's law. For the Rao's law we have done that. So and if but if P sat is low, we can write Fi star equals to, if P sat is low, what you can write? Fi star Tp equals to, if P sat is low, I am giving some approximation. If P sat is low, what you can write? Fi star equals to F sat, because this integral will go, right? This exponent term will go. Okay, I am assuming that solution pressure is actually lower side. It's okay. But in that case, F sat is the saturation fugacity. Saturation fugacity is related with the saturation pressure. Saturation fugacity is related with saturation pressure. Via what? Via the saturation fugacity coefficient. Because we know that F by P is nothing but phi. F sat by P sat is nothing but phi sat. F sat equals to phi sat P sat. That's the way we feel it. So we have phi sat Pi sat. Okay, so it should be phi I sat P sat. Am I correct? Yes. So go to the FIL equals to FIB. What will you get? FIL equals to FIB. You have gamma I xi Fi star, which is also phi IB P Y. You can also write this as gamma I xi phi I sat P I sat phi IB P Y. Okay, so far nothing much I have done. Okay, so what we have assumed here? We have assumed this pressure in the liquid system is very low, and P sat is also very low, P is also very low. So they are very low. That's why the integral can be neglected. Third case I will show when the integral cannot be neglected. The question was supposed to come from you. You could have asked, sir, what will happen if the integral is not neglected? Can't you solve it? That's called high pressure approximation. Yes, you can solve it. That's what I will end. I will discuss, and with that I will end the recording equilibrium. So at low to moderate pressure, up to 10 bar pressure, we can write phi IB equals to phi I sat. That's very important approximation. This approximation at up to 10 bar pressure is phi IB equals to phi I sat. After that, it only phi IB equals to phi I sat. Okay. Up to 10 bar pressure, phi IB equals to phi I sat. Okay. With that, we can see your gamma I equals to YIP equals divided by XI PI sat. For Rao's law, gamma equals to 1. We had YIP equals to XI PI sat. If the Rao's law is not valid, you are getting the gamma I is nothing but YIP by XI PI sat. So equation 4 reduces to Rao's law if for the ideal case, and now the situation is if you want to calculate the pressure, total pressure, the bubble pressure or due pressure calculation. Dynamic pressure calculation is very easy. Temperature is a problem, as you have seen. You have to use a iteration technique. So for the pressure calculation, we have y equals to summation yi, I equals to 1 to say n equals to 1, and summation yi p equals to p, and we have p equals to summation I equals to 1 to c, and say c gamma I xi pi sat. Because YIP you can obtain from here. YIP you can obtain from here because p equals summation gamma xi pi sat. So now, this question you asked me earlier, how to determine experimentally activity coefficient model? If I want to determine experimentally activity coefficient, we have done so much models. Now the time has come for the experimentalist who will be going to do experiment. How to determine activity coefficient by experiment? So next topic I will cover, determine or experimental measurement of activity coefficient. Experimental measurement of activity coefficient. Experimental measurement activity coefficient. So first step, obtain the pressure, obtain low pressure VAD data, which is gamma I YIP by XI PI sat. Next step, okay, what actually is given will be PXY data will be given, like the previous problems. We have done previous one long back. PXY data will be given. From that, it is possible to calculate the PI sat for temperature also is there, and from there you can actually get gamma and gamma 2 experimental. I will just discuss a problem. Choice of proper model. Choice of proper model of excess gives you energy. Excess gives you energy. That is small GE by RT. That is very important. Choice of proper model. Because your experimental activity coefficient would be directly telling with your model. You can have your own model, no problem. That's the way the all models have been developed from experimental data. All these models, unique, unified, everything, they have been developed. This basic G by RT, nobody derived. They said this is the G by RT model. You derived it in gamma. You can see that. Basic G by RT people gave. They didn't say how it came. They actually did it by experimental data that I will show. In gamma 1, gamma 2, you have done it. In gamma 1, gamma 2, you have done it. And those things will satisfy the Gibbs-Duhem relationship. Okay. Next thing is procedure to obtain PXY data. Determine PI sat for I equals to 1 to C at a specified temperature. At a specified temperature, calculate gamma I from experimental data. From experimental data, Xi, Yi and P will be given. Calculate molar gives you energy G by RT, which is summation Xi ln gamma R. You know that. Choose models of G by RT. Choose models of GE by RT. Earlier you did G by RT experimental. Now you got the model. Next step is comparison. Such that this model such that norm of G by RT model minus G by RT experimental 2 norm. 2 norm you have done in maths. 2 norm have you done in mathematics, mathematical and chemical engineering. 2 norm. Calculate 2 norm for experimental data. The vector space. G by RT model minus G by RT experimental. Norm of that should be less than equal to epsilon. That means if it is, then that is a proper model. If not, choose another model. Okay? And then calculate gamma. Once the model is actually given, you can calculate theoretical activity coefficient. After a model, you can calculate, determine gamma from the model. Determine gamma I from the model. Ln gamma I, which is 1 by RT rho GE ln gamma rho N1 TP N2 for binary system. Then last step is determine Yi from each xi, determine yi using, you can say using gamma I xi pi sat equals to yi. So that's the way one can actually get pxy diagram, and so on. First you go for the pressure, then you go for the iterative process temperature. Iterative process is already done. So one is the two things: bubble pressure or bubble temperature, dew pressure or dew temperature. Bubble pressure, dew pressure are very easy to calculate because you don't need any iteration. You have seen earlier. But bubble temperature, dew temperature is not that easy. You need to have the iteration guesses from the entire equation. So let's look at the problem in the problem set 4. The following very data. I don't know what the problem number. The following very data, problem number 3, I guess. Problem number 3 of problem set 4. The following very data for the system benzene and pentane at 60 degrees centigrade has been reported based on experimental observation. Assuming that the 3 suffix Margulis equations, so they are giving the model. Assuming that the 3 suffix Margulis equation adequately represents the very data of this system, determine the Margulis parameters, compare the external data with the net calculated from the Margulis equation. So you can see that in the next page, there are a lot of data given on the pressure pxy, pressure in terms of torque. Okay, pressure in terms of torque is given, which is 1, 2, 3, 4, 5, 6 data are given. pxy. Okay, so we have entire equation. Log 10 pi sat, which is ai minus bi by t plus ci. The entire equation, right? Benzene and heptane ai bi ci are given or not? Yes, they are given. Next table. Benzene and heptane ai bi ci are given. Okay. So temperature is given. How much? 60 degrees centigrade, right? So now we can calculate the P1 sat and P2 sat, the first step. P1 sat and P2 sat. P1 sat and P2 sat. You should be doing fast because this type of calculation is not the first time. We have done it earlier. P1 sat and P2 sat. P1 sat and P2 sat. P1 sat and P2 sat. How much is P1 sat? P1 sat is 391 plus 50 torque. And P2 sat 210.58 torque. Okay. Next step is what? Here are the steps. Tell me the steps. We have calculated P1 sat, P2 sat. Is that end of the story? What will you do next? What will be next one? Your P given, Xi given, X1 given, Y1 given. We have ln gamma 1, ln gamma 2, and from summation of Xi ln gamma Y, you will get experimental Ge by R. Right? And if you are saying 3 suffix Margulis equation, what is the formula? 3 suffix or 2 suffix? 3 suffix. What is the 3 suffix formula? Margulis equation. Do you remember? Ge by RT equals to 3 suffix Margulis equation formula. I have done very beginning, I guess. Very beginning, I guess I have done activity coefficient. 3 suffix Margulis equation. I proved also. What is that? What is that? Anybody can tell 3 suffix Margulis equation formula? Even simple thing we really struggle to find out. I don't know what I am teaching in the class. 3 suffix Margulis equation. The first activity coefficient models I have taught in the class. The first activity coefficient model. So nobody could find. I don't know how I have so much patience to teach you. I really appreciate my patience, not yours. Everybody is prompting. Please try to find out your own notebooks, not other to see others. Because I'm really scared that you cannot find. Anybody could find? 3 suffix marvelous equation? Yes, madam. Why are you not raising your hand? Do you think that I don't treat me like a barking dog because I lose energy. I don't use microphone. I don't understand. I'm sure you don't understand my pain, what I teach. Okay, I'm sorry. You don't need to volunteer. You treat me like dirt. That is fine. I don't treat you like that. I respect you, and I don't want you to lose energy. Let me lose the energy. I don't want any volunteership from you. Your name is what? Ugan. Yeah, you are well known. Yes, anybody can volunteer? Anybody else? Rahul also failed, right? To volunteer. I don't know what's happening. You lost interest on studies. I guess so. You are not feeling well. If I come to the class and say that I am not feeling well, what will happen? I just come one day to the class. This is my 52nd lecture. I am a human being. You are also a human being. You can say I am not a robot. Of course, I appreciate. I am not a robot though. But if I say I am not, because I do research till 2:30 every day. If I say I am not feeling well, would you like it? Of course not. Music is right. I really appreciate Rahul's concern. I wish you all the best in studies, but this attitude is not correct. Yes. That's all. 3 suffix, marvelous model.
G by RT, x1 plus h2.
Yeah, G by RT equals to?
x1 plus h2, z1, z2, z1 e plus.
Okay, I will just tell the simplified model. A21 x1 plus A1 2x2 into x1 x2. A21 x1 plus A1 2x2 into x1 x2. Okay, was it available in your notes? Okay, please verify that. Please verify that one. The 3 suffix, basic 3 suffix for modulus equation model. Okay, I will not argue on that. So we can see that this will lead to GE by RT x1 x2 equals to A21 x1 plus A1 2x2. That means G by RT x1 x2 is a A1 A21 x1 plus A1 into 1 minus x1. So that's the linear function of x1, like y equals to mx plus c. So what you can expect, GE by RT x1 x2, if you plot with respect to x1, it will behave like this. So that's the way one can choose the model. Now let's see what your GRT experimental data and whether you can fix the. So then it will give you the slope will be the slope and intercept, and that will give you A21 A12. Once actually you ask me how to determine A21 A12, that's the proper way. Okay, so let's start. First data 237.60. 237.60. 237.60. X1 is 0.087. Y1 is 0.187. Okay, so what is that? Ln gamma 1. Gamma 1 will be what? We know that. Experimental. YIP by XI PI sat. P is given 237.6 top. Y1 is given 0.187. Divided by XI 0.0.087. P1 sat is given 300 something, right? Top. How much is the ln gamma 1? You get the G by RT, you get the gamma 1, take ln, you get ln gamma 1. How much you are getting? How much you are getting? I have given everything, the steps. You have to put the values in the calculator, get the answer. What? Yes, madam, 0.2635. And next one? Next one is? Ln gamma 2. Ln gamma 2 is how much? Ln gamma 2 is how much? Yes, ln gamma 2 are stuck, right? Minus ln gamma 2. Ln gamma 2 is minus. I am not seeing that. Ln gamma 2 is how much? 0.0047. What is G by RT? X1, X2. G by RT, X1, X2. G by RT, X1, X2. G by RT is nothing but summation of xi ln gamma 1. First calculate G by RT, X1, X2 is there, divide by X1, X2, get the value. It's all very simple. How much? How much is G by RT X1 X2? G by RT X1 X2. 0.3450. Okay, so all those things you can actually fill it up. You go home and fill it up, and in a draft paper you can see the data, experimental data. You do least square estimate. You do least square. How do you do least square? For least square, you don't have to do a graph paper. First of all, one thing I have to tell you that, did you see your notes, how you got it? What was the 3 suffix model? That's why I didn't get the answer, I was a bit disturbed. 3 suffix model was originally given as ln gamma 1, which is x2 square into a2 plus 2 into a21 minus a12 x1. Is that correct? I get? Yes or no? Second model, second activity coefficient model. First model was very easy. Second activity coefficient model is called a 3 suffix model. I proved, I think, this one. Did you get it from your notes? Yes or no? Yes? Only Devan told yes. Devan told yes. Only one you got it, right? Did you get this one? Yes or no? Yes. From there, can you get the simplified form? So what is that? What is correspond to? G by RT. This model, this corresponds to what is G by RT? G by RT. What's the first model we have? You are looking at good equations, sir. What kind of notes you have? Dangerous. The way you are doing the notes is dangerous. So this is the basic model. Okay. This is the. Where is that? Your notes is not that much visible to me. Okay, let me look at my notes. Impossible to find something from your notes. I don't know. I guess you will become teacher, or you are not. You won't become teacher. If you don't become teacher, okay. If you become teacher, then you have to convince your student. Yes. So if you look at the 3 suffix formula, if you go to the before that one is Van Der equation. From before Van Der you have ln gamma 1, right? Yes, so you have got 3 suffix normulus equation. It is Q1 3 suffix normulus equation. It was given Bx1 plus Ax2 into x1 x2. Did you get it? I had to really struggle so much to get you the Van Der, to get you the 3 suffix formula is there in the notebook, and you are struggling to find from the notebook. There's a height of the level. I have done the Wolff's equation, and the from Wolff's equation we have got 2 approximations, right? Let me check it out. Lot of derivations I have done. I have done Wolff's equation. There are 2 approximations. One is the 3 suffix normulus equation. One is Van Der equation. 3 suffix you have Q1 equals to Q2. Van Der A by B equals to Q1 by Q2. So Q1 equals to Q2. If you look at the G by RT formula, which is Bx1 plus x2 into x1 plus x2. That's right. Did you get it? Yes or no? No. How many are no's? I just want to see the no. Did you get, madam? It is there before Van Der. It was written in terms of B. I put A21 and A12. So I have to really struggle so much. I don't know what I am teaching, and sometimes I feel frustrated. I feel I should continue teaching, but I don't know. I am really completely gone. Okay, anyway, so G by RT x1 x2 will be given with respect to x1. So we can, so how to do least square? Least square fit. You have some data. You have to get y equals to ax plus b equation. How to get a and b from the data? Do you know that?
So we have to write summation y equals to a summation x.
So you have data xi, yi. Okay. So xi is this one, yi is g by rt x1 x2. How to get a and b, slope and intercept from the data? What's the formula?
One equation would be summation y equal to a summation x plus b.
What one equation? I want a and b. Don't give this kind of thing. If I start giving the class, how do you feel? I should have taught like your way. Just do something, go. I'll be happy. Now I'm sweating, and I know how people are responding to me. Okay. So next class, I am going to out of the class. Next class, I want to have the complete answer. What is a and b? I do not expect. I am requesting you. You know that. Even if you don't do it, I will not demand. I will do in the class. Because I will start demanding. You will put all those posters and everything. I am scared of you. Thanks for your attention.